Hello interwebs, welcome to Adamant IT. Today I'm going to be sharing with you the Uniformation GKtwo Resin 3D printer. Now I did a video not that long ago on getting into 3D printing using my Creality Ender 5 S1 Pro, but that's an FDM printer. The GK2 is Resin, and that means it works very, very differently. So today I'm going to show you how I got started with Resin 3D printing, what it's good at, what it's kind of a pain in the ass for, but also how the Uniformation GK2 has just suddenly appeared as the absolute weapon of choice for Resin 3D printing. So let's roll the intro and get into it. Let's start with a quick overview on how resin printing differs from FDM. So fused deposition modeling, or FDM, is the one that most people think of with 3D printing. That's when you have a spool of filament that you heat up and extrude, and you extrude that in a pattern layer by layer until you build up a 3D model. The print head will sit on some kind of gantry, or the bed will move or something else, and it will just simply move the extruder around to wherever you need to extrude your filament to. So, as I say, this is what most people think of with 3D printing. You get a very identifiable result. FDM 3D printing has a very visible look to it. It has a very visible grain to it, and you can get it in all kinds of colors as well, and styles and finishes. The prints are fairly strong, but they're not very good at doing high detail work. They can do some details, but the really small stuff, if you're trying to do models or very delicate stuff, will either get lost or it'll be extremely delicate and just not hold up under scrutiny. Likewise, it takes a lot of tuning and fiddling to get an FDM printer set up in such a way that you don't have just small defects here and there. For a single model or part, FDM is reasonably fast, and you can tune an FDM printer to go really fast, but it's limited by just simply how much it has to print. The more stuff per layer, the longer it will take. So if you print 10 times your model on the print bed, it's going to take 10 times the print time. And when 3D printing already takes hours on end, this can stack up really fast. Resin 3D printing takes this whole concept and literally turns it on its head. So at the bottom of the printer, we have this vat of liquid resin, and the bottom of the vat has a transparent sheet underneath it that's slightly taut, almost like a drum. So we have this vat of liquid resin, and underneath that clear sheet is a very high resolution LCD and a UV lamp. When printing starts, a metal build plate is lowered upside down into the vat all the way to the bottom, leaving a super thin layer of resin under it. The LCD displays a negative silhouette cross-section of the first layer of the model, allowing the UV lamp to shine through and cure the resin in that cross-sectional shape. Then the build plate moves up a layer, the image on the screen updates, and the UV lamp exposes it again. This process repeats layer by layer, and a solid model is slowly lifted out of the vat, attached upside down to the build plate. Unfortunately, this means that most of what's going on while the printer is running is hidden from view, so there's not really a lot of footage I can show you of the printer in action. But in the second half of the print, you will often see the build plate getting just high enough to see the lower layers of the print upside down, lifting up out of the vat. So the printer comes as a fully assembled unit. There's no construction required here. You don't have to build up the frame or anything like that. And it's also fully enclosed with this flip-up front door, which is big, thick plastic. It's very strong. It's pretty heavy duty as well. So this keeps the worst of the fumes contained in the unit. And on top of that, we have a built-in air filter at the back here. This is an interchangeable carbon cartridge, and there's a fan that cycles air through it while the printer is switched on. So it's running all the time while the printer is turned on. So these are interchangeable, and you can just pop that out the back and pop a new one in. However, this isn't a magic bullet for the fumes. I'll talk more about that later. The main LCD on the GK2 is this big 10.3-inch 8K screen. Yes, you heard that right. It's 7680 by 4320 pixels. And combined with a typical layer thickness of just 50 microns, that's 0.05 millimeters, you can start to get an impression on the kind of detail that these things can actually do. An FDM printer at very fine, like tuned fine settings with a small nozzle, you could get down to 100 microns. So you can do at best twice as thick as this thing is on normal settings. So yeah, you get the idea. Underneath this LCD, we've got the UV lamp, and then there's also a built-in heater that keeps the resin at optimal temperature, which is about 25 degrees centigrade. So along with having this enclosure keeping warmth in the unit, you're going to have less issues with goopy resin that doesn't flow properly and leaves defects in the models. This is actually kind of a big deal because while I'm not an expert on the 3D printer market, having a casual look around, I actually had a lot of trouble finding many other printers, if any, that had a built-in heater. It's not a standard feature. And considering how important it is to keep your resin at the correct temperature, this is a really big deal. So moving up from this base, we've got a 700 gram resin vat, and that just clicks onto these rails here. So it just slides in like that, quick release. And that makes it super easy to take in and out if you need to refill it, drain it, clean it, or you could have a second tray with another different type of resin in, and you could just swap them out without having to drain and fill your vats every time. And then also it came with this natty little cover, so when you're not using it, you can put the cover over the resin, and that'll also keep the fumes down. And just covering this up I found is extremely effective. And then finally we've got the build plate up the top here, and this comes pre-leveled, which I was kind of dubious about at first, but I haven't touched the leveling system on this printer at all through any of my testing, and it works just fine. Didn't have any issues at all, as opposed to, you know, even my Ender 5, which does have fairly sophisticated self-leveling, that still needed leveling and some tweaks to really get set up correctly. I didn't touch this, it just worked. So that build plate is held on with this nifty clamp. So that comes up, and then the build plate slides off. And so when you've just finished a print and you're trying to move things around, being able to do all of that one-handed, really useful. So to control the printer, we've got this 5-inch color touchscreen down the bottom. We've got the power button there, which is a big clunking power switch. That's not a soft power button, it's an actual proper clunking, this switches the power on and off kind of button. And then we've got a USB port on the front, and there's another one around the back as well. And you can plug USB drives into those ports, and you can also plug in a Wi-Fi adapter for the optional Wi-Fi functionality, which I'll talk a bit more about later. So given that the GK2 comes pre-leveled, there was actually almost no setup I had to do short of simply buying a bottle of resin and filling up the vat. So now I'm going to take you through the process of actually printing something on this step by step. But first we're going to need something to actually print. So let's talk about slicing. I covered slicing in detail back when I reviewed my Ender 5, but as a quick recap, to 3D print something we first need an STL file, which is a very common and simple 3D model format. So you can download STLs from a variety of different online libraries like Thingiverse, Printables, and a whole manner of other indie websites where people upload models that they've made. You could also make your own STLs if you have any familiarity with 3D design software like Blender. And again, I showed how you can do that in my Ender 5 video, so be sure to check that out. So the next step would be to import that STL into your slicer of choice, and that slicing software will figure out how to 3D print that model. So in the case of an FDM printer, that means making a list of instructions on where to move the print head to, how much to extrude, and then where to go next, and so on and so forth. But in the case of resin, instead of making those lists of instructions, we're going to literally slice the model. So we're going to slice it into the number of layers, with each one being the thickness that the printer can manage. So each slice is a cross-section of the model that the LCD will display and the UV lamp will expose the resin to. Now, Uniformation have two slicers that they advertise as being compatible with this printer. There is GKtwo slicer, which comes with it, and this seemed to be a kind of minimum effort gets the job done software, because technically they've got to give you something that will make it work. That being said, when I downloaded the latest version during editing to get B-roll footage of it, I found that the latest version was much more usable, so it is entirely viable. The other option is GKtwo, and it is very obvious that Uniformation want you to use GKtwo instead. So there is a free version of GKtwo and a pro version of GKtwo. The Pro version is subscription based, and while the GK2 did come with a 3-month trial, I needed to provide payment information in order to activate that trial. So I didn't. However, there is a 7-day trial of GKtwo which doesn't require any payment information up front, so I did test that out. So to quickly summarize, the free version seems to do most of what I would typically expect from a slicer. It allows me to add and position models, rotate and scale them, add supports, preview, and save the sliced file. The Pro version probably has more depth to it for advanced users, but the main difference I noticed is that it had a bit more of an intuitive interface to it. There were more options, and there was a much clearer separation of setup, slice preview, and export. So while the Pro version does seem to be a bit more user intuitive and have more options, I don't think it's required at all. And given that I really don't fancy paying a subscription to use the software with the $850 printer, yeah, we'll get to that, GKtwo Free is exactly what I'm going to use for this moving forward. So let's start by printing something familiar that we've all seen before. Here is Benchy, the benchmark boat that everyone prints on their 3D printers. Benchy doesn't need any supports or anything like that, so I can just simply drop this into the slicer, slice and export. The CTB files that GKtwo produces are really big in comparison to G-code files, but one of the nice things is that it does bake a thumbnail of the model into the CTB file. So when you go to print it on the printer, it will show you a preview so you know you've got the right thing, and that's kind of nice. So we've got our print file, and there's 2 ways that we can actually get it onto the printer. We can either bring it in on a USB flash drive that we plug into the front, and then we can either print directly off of that drive, or I can copy it into the 7 GB of internal storage. Or if we have the optional Wi-Fi adapter plugged into the back, which I do, we can also transfer it over a network. The GK2 doesn't have a web interface or anything like that I could find, but instead it basically has a built-in file server like a NAS drive. So you would connect to it like a network attached drive, which you could also map as a mapped network drive if you used it all the time, and copy the file over that way. And I found this was really useful, and it's how I've been doing pretty much all of my prints. So now we've got our file on the GK2, we can select it from the menu and hit print. So the printer will now start heating up the resin until it gets to 25 degrees to ensure an optimum print temperature. And then the build plate plunges down into the vat, making the resin level rise to an amount that makes you really think it's about to spill it all over the place. And then it just stops. And it just sits there. Now, the first layer is exposed for much longer than the rest, but even then, the only thing you'll see while it's running is just a tiny little wiggle now and then as the build plate moves up and down just to pull more resin in under the build plate. And as I mentioned earlier on, if the build is big enough, later on in the print, you'll start seeing the bottom of the model coming up out of the pool of resin. But this is basically it. That's all you get to see. So it's a bit of a shame because it means that it's kind of hard to know if the print is going okay or not. The only way you're going to know if something has gone horribly wrong is right toward the end of the print, when if the build plate comes out of the vat and there's nothing on the build plate, then you have a block of plastic stuck at the bottom of your vat. Whereas with FDM, you can keep half an eye on it and you're going to see fairly early on if the print is likely to fail or not. But that's just how the tech works. There's not really anything that we can do about this. One thing that I did notice is that the time estimates you get from the printer are wildly different to what GKtwo was telling me. Now normally with FDM I find the slicer tends to be a lot more accurate for print time estimates because it knows how big each layer is, so it can account for how long each layer will take as opposed to just simply how many layers are remaining in the print. Resin printing works the other way around. Because you're printing an entire layer at a time, it doesn't matter how big that layer is, you expose it for the same amount of time anyway. So I found that the printer, which was just simply estimating by how many layers it had left to go, was giving a far more accurate estimated time. I think one of the reasons for this is that every layer, every other layer or so, when the build plate goes up and down slightly, that takes time. It takes a couple of seconds for the build plate to do its little wiggle. And I think the printer is aware of this because it's counting how long each layer takes, whereas GKtwo doesn't know how long the printer takes to do a layer, so it's just simply taking the exposure time and multiplying by the number of layers. So the printer's estimated time remaining seemed to be pretty on point based on my observations. So once our print is done, the build plate will fully retract all the way up to the top, and we'll have a print hanging under the build plate. So now comes the time where the ball ache of resin printing really cuts in. If we were FDM printing, we'd basically be done. You peel off your print and that's it. You've got a model. But with the resin printer, now we have to wash the print and cure the print. We've got to wash it because there'll be just a lot of excess resin on the outside because it's been dipped in a pool of liquid resin. And we have to cure it because it's only had just a basic cure done in order to speed up the whole process and make the whole thing stick together. We now need to do a final cure around the outside to harden it up. And because we now have to deal directly with the resin, we need to glove up and prepare a workspace to actually do this. I've been using sheets of cardboard to protect my countertops so I can make a mess and then easily clear up afterwards. You could also use like newspaper or something else if you wanted. The quick release clamp on the build plate makes removal really easy here, so I'll move it over to the workspace and then using the provide scraper I can carefully detach the model. I'll then give the build plate a wipe down and I can put it back in the printer so it's just out of the way. We're also done with the printer at this point, so I can put a cover over the vat of resin, close the lid and switch it all off. So to do the wash and curing, I bought the cheapest 2-in-1 station on Amazon, which was this Anycubic unit. And it's actually been really great. There are lots of cheaper options available, but they all seem to be just like a tub or just a light with a UV bulb in it. Nothing that actually seems designed for this purpose. So I put the print into the basket and then into the wash. You'd usually use isopropyl alcohol for this, but I'm using a water washable resin and it seems to work just fine, although apparently it can be a little bit more brittle than the alcohol washable stuff. The wash station has got a built-in stirrer at the bottom, so when I start it up, it'll automatically stir the water to wash all the excess resin off of the model. And then it automatically changes direction every couple of minutes, making these little futuristic noises when it spins up. Now we're washed, the model is looking much sharper. I recommend going overkill on this. The wash and cure by default gives 3 minutes, but I've actually found that doing like a 4-minute run, then shaking the basket around to move the model and then giving it another 4 minutes seem to get a lot more off. So I think this is probably an artifact of the water washable stuff as well. To get rid of the excess water, I give it a blow dry with my air compressor. You could also pat it or brush it dry. Alcohol will evaporate a lot quicker than water will, so you may have to do less work with drying if you're using an alcohol wash. So now we've got this model that's got this matte and almost rubbery feel to it. It's kind of neat, but it's also quite easy to mark with your fingernails. So now I'm going to take the wash container off of my station and put the turntable on. This station also has this extra bendy lamp which will reach awkward spots that the main lamp doesn't quite reach. The Wash and Cure 3 defaults to doing a 3-minute exposure, so I tend to do that and then I'll usually turn the model and then give it another 2 minutes. And again, that seems to have given me better results. If you overexpose, apparently you can make something that's too brittle, but I haven't really done a lot of experimenting with overexposure to see what will happen yet. Now we've cured it, we've got something that is hardened and has got a nice, shiny, pleasing finish to it. It genuinely feels like something I've bought at this point, not something that I've kind of just cobbled together myself. The results are fantastic. So let's compare this benchy that I printed with a benchy from my Ender 5. You can see the difference very clearly because FDM has a very noticeable grain to it, whereas the resin doesn't have any noticeable grain at all. If you look really close on like the handrails here, you can see the layers on these slopes, but it's a completely different scale to what FDM is doing. And if we want to give you kind of a hint as to the available detail we can actually do with this, well, here's a remix of the Benchy with a lattice hull. So now you get an idea as to why resin is king when you want to print miniature figurines. So I spent a week throwing various different models and prints at the GK2. Here's a keyboard opening switch tool, simple, much stronger than the FDM version. These sharp points aren't even slightly dulled after I used it to open 90 keyboard switches. Next I downloaded some models from Palworld that I found on Thingiverse and chucked those all in together. We've got a Lamball, we've got Chillet, Dinossum and Quivern. I used auto supports for these and it left quite a lot of pockmarks on the model. So this is possibly an optimization issue or just tweaking the slicing settings. At this point you probably need to start brushing them up and painting for best effect, but as a proof of concept this was 10 minutes of actual work on my part. I even printed a bigger Quivern too because I really liked this one. However, let's get that big thumbnail shot, the super detailed tabletop miniature that really showcases what these machines are capable of. A bit of Googling landed me on CG Trader and I found this Croc Tribe by Pork U. And if we look at the results I got from these models, you really see the true capabilities of resin. The detail here is astronomical to the point where you really have to hold it up to your eye to make out all of the details. You can see all the ribs in this Croc's mouth. You can even see the details on the little skulls around his belt. It's actually quite staggering that this is done with what is essentially a consumer product. So with results like this, it's kind of easy to ask yourself, why would I ever use my FDM printer ever again when I've got something that can do this? And well, that kind of depends on what you're printing. If you're printing detailed models and figurines, then the resolution and the detail that the GK2 can achieve is out of this world, and there's absolutely no contest whatsoever. But if I'm just trying to print simple parts or just stuff where the detail is less important, just brackets and things like that, FDM is significantly less hassle. And also, because you've got just a little bit of bend in it, it might be stronger in some instances because it doesn't have that brittleness that the resin will have. It's not going to chip in the same way that resin will. And of course with FDM I don't have to do any washing or curing or cleanup afterwards either. There's also the speed factor as well. If you're printing just small parts, a well-tuned FDM printer will almost certainly be faster than resin printing. But here's the thing, the GK2 is printing an entire layer at a time, no matter how big that layer is. So at the same time as I printed a single Benchy on the Ender 5, I could put 10 Benchies on the build plate and it would still take the same amount of time. So whereas the Ender 5 would need 10 times the amount of time to do 10 Benchies. And so that means that for a single object, my Ender 5 is probably going to be quicker. But if we're doing a whole set of models, then it's not going to be able to touch the GK2 when the GK2 is printing everything at the same time. You might also want to consider what kind of finish you're actually aiming for. So resin has this very unfinished plastic look to it. And you can get a nice shiny finish as well. These figurines I went quite hard on them. I did a lot more washing than I did on other models and I cured them for a much longer time as well. And I got a much more pleasing, shinier finish from them. So obviously figuring out your wash and cure settings is going to help as well. And that's just something you will need to do some figuring out with. And they look pretty good bare on their own. But with FDM printing, you can use a funky coloured filament that has a particular matte or satin or shiny finish to it. There's more colours available, and that very characteristic FDM grain that you get, that is a desirable look in some instances. It looks cool, it looks custom. And so depending on what you're doing, that might look better than just a chunk of plastic, depending on what you're printing. I noticed this especially with the slime VR cases that I was making. The resin one, while it was smoother, looked very unpolished, shall we say. Although it's worth noting that that's nothing that a very quick spray paint of base primer wouldn't fix. So both types of printing have got their strengths and weaknesses, and I know that's kind of a cop-out answer, but basically you need to consider what you want to print. For small parts and prototyping, FDM is just completely fine if I'm honest. However, for figurines and miniatures, resin all the way, no questions, no argument, end of discussion. Okay, we need to talk about ventilation. Resin is nasty stuff. I've been using the water washable resin, which is apparently less bad for fumes and smell, but if this is less bad, I hate to imagine what the regular alcohol washable stuff is like. I've been using the GKtwo in a fairly large workshop, and whenever I'm soldering or running a 3D printer, I will have a door open and a fan on, circulating air in the room. And that's done a pretty good job of keeping the fumes down. But as an experiment, I ran the GKtwo overnight with the fan off and all the doors closed, and when I came in the morning, I was not hit with a wall of 3D printing fumes. I did not walk in and go, ooh, kind of thing. It was fine in my large workshop. So to me, that suggests that the enclosure and that built-in charcoal filter is doing a pretty good job of dealing with the fumes. But this is where I think there is a trap to these things. While I was testing the printer, I saw another video by a YouTube channel called Keep Making, and he's running a resin printer in a very enclosed space in a shed, and he's got a heater on to keep the temperature up and all the rest of it. So fumes are a big problem for him. He brought a proper air pollution meter that measures TVOC, that's total volatile organic compounds. That's the poisonous toxic part. And then he built this big custom charcoal filter, very akin to what these are using. And he did a test where he ran the 3D printer with this running and the air pollution meter. And even with that big charcoal filter, the VOCs, which again is the nasty bit, were not getting filtered. The smell was gone, the actual toxic part was not gone. Now, I'm not a scientist, but he says he's got a lot of experience with working with toxic stuff like this, and that simple test looked pretty conclusive to me. The air filters that we're seeing in these modern resin printers, they will remove the smell, but they don't make the air safe. So it's nice to have this filter, but it's not a substitute for ventilation. Do not run these resin printers in an enclosed space with no ventilation. So coming back around to the GK2's interface, let's do a quick tour of the high-level menus. The home screen that we start on here has got a really good summary of information. It shows us if we're connected to the Wi-Fi, current resin temperature, and it also shows us storage status just on the home screen here, which is handy. So you can see if we have a USB drive plugged in, we can access that directly and see how full it is. We can also see how full the built-in storage is at any given time. It's got 7 GB of available eMMC storage, which is nothing to write home about, but it's fine for what you need. It's not like you're going to store your library of prints on one of these things. In fact, so much so that this data cleaning button here literally is just nuke the internal storage, which in a way is kind of nice because I've got a whole lot of clutter on my Ender 5 that I printed a long time ago that really doesn't need to be there anymore, but I can't be bothered to go through and tidy it up. As you can see, it does time out after a while and just goes to this little screensaver. I'll talk about that in a moment. So if we go to built-in storage, we can just browse what we've got on the documents. There's no folders here, it's literally just what is in the internal storage. So if you're doing repeat stuff, I can just say, hey, I want to do this lattice benchy again, and it will load that up and it will show me the print. And then at this point I can hit go or I can hit delete. So if we go back again, file sharing, if you have that Wi-Fi adapter plugged in and connected, on here you can set a username and password to access it, and you can hit you hit the save button there for some reason or other, and it will tell you the current IP address. I've not been able to find a way of setting this IP address manually, which I'm not a fan of, because like most people, I use DHCP, which means every time I turn it on, I have to check to see what IP it's set itself to. There's ways of solving this problem, but you shouldn't have to. It should be part of a basic network setup to set a manual IP. If we go over to the printer setup section, we can manually adjust the Z axes, so we can raise and lower the build plate. We can do exposure tests, which allow us to visually check that the UV lamp and the LCD are working correctly. We can do the vat cleaning, which will essentially expose a single layer on the bottom and allow you to peel off a nice clean layer of resin to ensure that the bottom of the vat is empty. And then we've got system update. The system update doesn't seem to be particularly useful. It says no updates available, but there's no button to say like check or anything like that. I've never seen this show anything. Then we've got the settings where we can set the language, connect it to a Wi-Fi network, and then there's more system settings in here, such as you can set a name for it, you can change the beep sound, turn on the heater and set the heating temperature, and so on. And then finally we've got a documentation one where there's information, error logs, and other useful links. When I started using the printer, I was kind of wondering where all the other settings were. There wasn't a huge amount in these menus, but the thing is, you don't actually need much more than that. There's not 1,000,001 settings that you actually need to tune with the printer itself. Everything else is really in slicing and your wash and cure setup. The actual printer itself is kind of just set and forget. I like how clear the color touchscreen is, and it feels really responsive to use. I like the big clunky anti-vandal power switch as well, big fan of that. But the screen isn't really angled in a meaningful way, and it's kind of annoying having to bend down to look at it every time I'm actually doing anything. It's not really comfortable to use from standing height. Unless you had the printer like up high, which I just don't think you would. So, you know, it could have done with a little bit more angling there, but whatever. There's also some kind of odd choices as to how the screensaver on the LCD works as well. On a printer where you've got no visual indicator of progress, it's fairly obvious that you're going to want some kind of progress bar and tracking on the screen itself. And it has that while it's printing. But the thing is after a fairly short amount of time, the screensaver cuts in. And that screensaver is just this spinner that just goes touch to activate the interface. And you might think, well, you know, it's turning off the screen to save power and preserve and, you know, dim the backlight to save the backlight and things like that. But also it doesn't. It does dim the backlight, but it never actually switches off the screen. So if the screen is going to be on all the time, I'm not sure why they bothered having this screensaver there. Why not just have it display the progress all the time? Sure, dim the backlight, but the most useful thing that you can display on that screen, even while the backlight is dimmed, is a basic progress bar. This would be really easy to change in software, so maybe that's something that they could do in a firmware update at some point. It would also be nice if the Wi-Fi functionality added some kind of web interface, which again would allow me to see progress and ETA by remote. I do like the file server interface though. That feels like a lot less hassle than using the web interface that my Ender 5 has. The file server interface doesn't allow me to start a print by remote, but also this is kind of like having an eject button on your DVD player. It's not really very helpful when you've still got to get up and go and get the disc out of the player anyway. Likewise, you know, I still need to walk over here, switch this on to push the go button anyway, and I'm going to have to come over when it's finished. So, you know, it doesn't really matter if I have a remote control for it or not. Except for a bottle of resin and whatever wash and cure setup you're going to use, the GKtwo comes with all of the accessories you'll need. It comes with a scraper, with replacement screen covers, it comes with sets of gloves and even a thumb drive. All the things that you need are all there. And of course it didn't require any leveling or assembly to get started. Literally pour in the resin, switch it on and just print a test model. So with that in mind, let's talk about the price of the printer. The list price on Uniformation's website is $850, and that seems eye-wateringly expensive if you do a quick search for resin printers on Amazon. But this price gets more complicated when you factor in the functionality that this printer has, not just in features, but in performance. As I mentioned, I'm kind of new to resin printing, but one of the things that I did discover is having a built-in heater is a really big deal and is probably the reason why I had very little problems getting up to really high detail models with no real fettling at all. For other people using cheaper resin printers, especially in colder climates like the UK, where they're going to have quite a lot of trouble getting the room temperature up to 25 degrees in order to keep that resin flowing, having the built-in heater just takes away all of that trouble. I just switched this on and just started printing, and it just worked. Convenience is expensive, and this is incredibly convenient. You could mod a cheaper printer to do all of this, but if you want to just get started and not have to learn to be a 3D printing mechanic, it wasn't actually until I started writing the conclusion to this review that I started looking around at what other people were saying about the printer and the price point of it. I don't do a lot of research in advance when I'm reviewing something. I like to just bumble into it completely blind so I can just give my completely unbiased blind opinion of my experience using the product. But once I've done that and I've sort of tried and had a go, I'll then have a look at what other people are saying, what other people are doing, to see if their experience matches my own experience. And it seems like I just made resin 3D printing look really easy because this printer does everything for you. If you want to start printing without having to get into the weeds of printer setup and tuning and thermal control and vat heating and room temperature, the GK2 is very much what you want. And my experience with it has been absolutely fantastic. I'm really happy with how my maker bench is starting to take shape now, and I'm just able to just switch these printers on and just print something with zero effort and zero planning up front. So I want to give a big thank you to Uniformation for sending me this sample of the GK2. There's links down in the description for where you can learn more about it. And I also want to give a big thank you to my patrons, my channel members, my Twitch subscribers, and everyone else who supports the channel, because it's with your support that when Uniformation said, we're sending you this, but you'll need to buy the other bits, I just went on Amazon and just bought what I needed in order to get started. You guys make it possible for me to just plunge into these things and get it done. So thank you very much for supporting the channel. I hope you guys enjoyed the video, and I'll see you guys next time. Bye for now.